Morning, welcome back. Hello, how are you? I've got a quiet audience today. Nothing going on in the chat right now. But hi, good morning. Leave me a comment in the chat if you're with us live. Thank you very much. We appreciate you. Let's go ahead and talk about what we're going to be working on today. We've got two sections. We've got 7-1 ratios and proportions and 7-2 similar polygons. Let's just jump right on in. If you're here live with us today, you've got the 7-1 and 7-2 skill practice that you picked up at the door with the unicorn. They looked like this. If you are joining us from the house, you can find these in your It's Learning. You can download and print, or you can work on them by editing the PDF and submitting that to me. All right, let's jump in. We're going to solve proportions. We're going to write some ratios today. And so our first step is to define what a ratio even is. A ratio is a comparison of two different quantities using division. So it's basically a fraction. We can express it three different ways. We can write either number, the word two, and then the other number. We can write it the first number, a colon, and then the second number, or we can write it as the fraction, first number over second number. In all three of these cases, we're not going to allow b, the second number, to take on the value of 0, because then we end up dividing by 0 and it hurts our brains. So here is the different ways that you could write it. Here is a ratio 32 to 18, and this is saying that 32 to 18 is equivalent to 16 to 9. And that's because if I were to look at 32 to 18 as the fraction 32 over 18, I notice that these are both even numbers, and I can divide out the common factor of 2. When I do that, I end up with a fraction of 16 over 9, which is the same as this other ratio. Nothing new, yeah? The hard part for you guys is when I give it to you in a word problem to figure out all of the different words that are being asked, especially if you're like me and you had to look up information about the sport of baseball because I don't know much about it. So when I'm reading this question, it says a player's batting average is the ratio of the number of base hits to the number of at-bats. And I had to look at what the word at-bat meant. When I looked it up, at-bat meant the number of times I actually go up and I have the bat in my hand and I try to hit the ball when it's thrown at me. It doesn't count how many times I hit it. It's just, did I go up and did I take a swing? That's an at-bat. The hits then, which is this column over here, is I actually made contact with the ball. And according to my word problem, it's a base hit. So that means I connected with the ball, I hit it, and as I was able to run around and end up on one of those little white bags somewhere along the way. I don't know how many of them I managed to pass, but I ended up on one before my turn was over. So here is, over this player's career, Ian Kinsler's career. Here's how many times he got up to swing at the ball in each of these years, and this is how many times he managed to hit and was able to run and stand on one of the white things for each year. This is the grand total over the 8 years that he played. I'm asked what's his batting average. Since it didn't give me a year, I have to go with the grand total of his career. So we took the number of hits for the grand total of the year, and then we divided it by the number of times that he went up to swing at it. His batting average then is this decimal, 0.273. I don't know if that's good or bad, but I now know what his batting average is. I suppose if I did this for a whole bunch of players, I could see which one has the higher number and then say, like, they're the better player, so I want them on my team. This example is exactly how you do the work in your skill practice for this section 7-1, questions 1 through 5. So if you'll make a note, an extra little jot in your notes that says this example 1 will help you with skill practice questions 1 through 5. And it doesn't seem like that's anything new. The thing that might be new though is this thing called extended ratios. And you can find this in your skill practice. This is questions number 12 through 15 on extended ratios. And here's how that's going to look. It says the ratio of the measures of the angles in a triangle is 3 to 4 to 5. Find the measures of the angles. Now what this 3 to 4 to 5 means is that the ratio from 3 to 4 is equivalent to this. The 3 times some other number to give me an angle measure of 3 times x. I can do that for all 3 of these values. So I get 3x as one of my angle measures, 4x as another one of my angle measures, and 5x as my third angle measure. Since I've been asked to find the measure of angles, I can use my triangle angle sum to help me write an equation that then is easy to solve. 3x, which is one angle, plus 4x, another angle, plus 5x, the third angle, equals 180. 3 plus 4 plus 5 is 12, and 180 divided by 12 is 15. And so x is 15. But I didn't get asked for x, I wanted the measures of the angles. So this angle measure here, 3x, is 3 times x, which I found to be 15. 3 times 15 is 45. If I do that for all the other angle measures, I see that this angle here at the 4x is 60, and this angle at the 5x is 75. I have found all the measures of all the angles in this triangle. Questions on how that one got done? I'm going to keep an eye on the chat to see if any questions come up in the chat. Meanwhile, let's take a look at this in guided practice number 2, because it's this one that those questions 12 through 15 are actually most like. It says, in a triangle, the ratio of the measures of the side is 2 to 2 to 3, which means I have one side length measure 2x, another side length measure 2x, and another side length measure 3x. And then I told the perimeter, add all the sides. The perimeter, 392. All right, so my grand total is 392. Since perimeter means to add all the edges, I'm going to add 2x to 2x to 3x, and that is equal to the total perimeter of 392. And I solve this equation the same way I did the previous one. Add up all the x's, divide by the coefficient, and I think I end up with something like 50 something. I don't remember. This is 7. So 392 divided by 7. Someone with a faster calculator than me, because I have to find my calculator and my desk is a mess. Oh, it is 56, 50 something. I was pretty darn close. Say that again. Where did I get 392? 342. I don't have a 342. This is 392. Oh, this? It's a plus. I'm writing with a mouse. And so it's not my best writing ever. I'm so sorry. Thank you for making sure that I clarified that. That was a plus. Now that I know the value of X, I can see what I was being asked to find. Find the length of the longest side. Since this part of my ratio has the biggest number, 3x is my longest side. And so the value of my longest side is whatever I get when I take 3 and I multiply it to 56. That should be 168. Is it? Grab a calculator. 3 times 56. One on your phone. Yeah. All right, so we did pretty good. This is exactly how you do questions 12 through 15. Promise you skip 6 through 11. Yep, I know. Because to do 6 through 11, we need to talk about the properties of proportions. An equation with two ratios being equal, that is a fraction equal a fraction, that's called a proportion. And if I take the top of one side and the bottom of the other, those are the extremes. The bottom of one side and the top of the other going the other way is the mean. You likely learned this as cross multiply using that butterfly technique. And I've seen a lot of teachers teach it this way, where you circle like this, and then the ones in this little bubble are multiplied together, and the ones in this bubble are multiplied together, and they're equal, just like that. This is formally called the cross product property. Cross product property. And it allows you to cross multiply and solve. And so that's what we're going to do. I'd like to work out for you, just as a reminder, I'd like to work out 3C for you. I'm going to do it right here, because one of the questions, I don't think on this section, but on the next, is going to create something that looks like this. All right, let's cross multiply. So I'm going to multiply the extremes together. That is 7 times z plus 4. And that equals the means multiplied together. So that's these. That is 9 times z minus 1. All right, and now I get to distribute and solve. So 7 times z is 7z. 7 times 4 is 28. 9 times z is 9z. And 9 times minus 1 is minus 9. Subtracting 7z from both sides gives me 28 on the left, 2z on the right. The minus 9 on the right is going to fall down because there's nothing under him. Add 9 to both sides to get rid of the minus 9 on the right. The left-hand side becomes 37. The right-hand side is left with just the 2z. And when I divide both sides by 2, I get 37 over 2. This example is how you would do the items on skill practice from 6 to 11, just like these. Give me questions in the chat or speak up. All right, let's take a look at 7-2 similar polygons. With similar polygons, we're going to solve problems with similar polygons, and we're going to do that by writing proportions. Basically, what we just finished doing, but this time we're going to do that in the context of, yo, I got some polygons. First up, let's figure out what similar polygons are. by definition, and so this right here is a definition. So if you need it for a proof or something, here is your definition. Your definition of cylinder polygons is that they have the same shape, but not the same size. So one could be really small, one could be really big, but those angles are going to be the same. And so two polygons are similar if and only if their corresponding angles are congruent, but their corresponding side lengths are proportional. So this means that the corners are going to have the same measure. They're going to be just as narrow or just as wide, but that the corresponding sides, when you write them as fractions, all of the fractions are going to be the same number. Notice how these letters are color coded. Notice how this segment right here on the top is composed of two letters from the first polygon, and then the bottom is the corresponding two letters from the other polygon. Just like with congruent polygons, the order in which you write the letters of the name of the polygons matter. Just like in congruent polygons, the first letter that you write, that corner corresponds with the first letter that you write in the other name. The second corresponds with the second, the third corresponds with the third, the fourth corresponds with the fourth, and so on. So if you want to show that polygons are similar, that's questions 1 and 2, you need to come in here and you need to find some way to show that the corresponding angles are congruent to each other. That is, they have the same measure. And you need to some way to show that if you were to write the corresponding sides as fractions, that all those fractions are the same fraction. If you can do that, then you can say that these segments are similar to each other, and this is the similarity statement that you're going to be writing. Make sure those letters are in corresponding order, and you use the symbol for is similar to, which is the hat for the congruence. You know how we took the equal sign and we put the tilde on it to make it the Mexican equals to stand for congruent? Similar is just take that tilde symbol by itself between the two names, similar to. Now the big hint on the big, not hint, the big heavy lifter in terms of, is this thing similar, is that fraction you get when you write the two sides, one side from one shape divided by the corresponding side of the other shape. That ratio, that fraction, is called the scale factor. The scale factor will depend on the order you're comparing things. Take a look at this first statement. It says the scale factor of triangle ABC to triangle XYZ. That means that the ABC triangle is getting listed first in my ratio, so it's on top. And the XYZ triangle is being listed second, so it's on bottom. The other statement says the scale factor of triangle XYZ to triangle ABC. Notice in this case, I have these backwards. Notice in this case, the XYZ is listed first. That means that the information from the XYZ triangle is on top. That changes your scale factor. So when asked what's the scale factor of shape to shape, make sure that you put it in the correct order, otherwise you're giving us the incorrect scale factor. Let's take a quick look into your skill practice. 1 and 2, you're being asked to determine if they're similar. So in order to determine if they're similar, you need congruent angles and you need proportional sides. So write those sides as fractions, check to make sure all those fractions are equal. If they are similar, you're going to write the similarity statement. That is, triangle ABC is congruent to triangle WXY. Don't forget to write the scale factor. The scale factor is that fraction that you wrote when you were looking at the sides to see if they were proportional. Make sure that your scale factor is in the same order as your similarity statement. So write your similarity statement first. If you find out that they're not similar, you have to explain your reasoning in a full sentence. Questions 3, 4, 5, and 6 is asking you to set up those proportions and to solve for X. So let's do one of those here. I'm going to do guided practice 3A as your example. And I'm sorry that it's a little on the blurry side. I did not realize it was going to be so blurry when I created these notes. Note to self, don't make them so blurry. Okay. This little phrase right here, all of these weird math symbols translates to triangle JLM is similar to triangle QST. And I wrote it out here in English for you. Okay, let's find out which side is which. So the J is listed first and the Q is listed first. That means the J and the Q are the corresponding corners. And then I have L next and S next. So L and S. And then I've got M and T. M and T. Okay, now that I can easily see which corner lines up with which corner, I'm going to work on 3A, which is find the value of X. So this side has a Y, so I'm not going to worry about this side. This is the side with the X. So the side that goes from the blue corner to the yellow corner, that's the one I'm throwing away for this particular problem because it's not helpful. That leaves me with blue corner to pink corner and pink corner to yellow corner on each of my triangles. So I'm going to do J over M, excuse me, JM over LM. And that's in proportion with the corresponding side. J corresponds to Q, M corresponds to T, L corresponds to S, and M corresponds to T. All right, JM according to my figure is 4. LM according to my figure is 6x minus 3. QT according to my figure is 2, and ST according to my figure is 3. And now I get to cross multiply and solve. And so this is going to feel exactly like what we did in the previous section. While I go ahead out and show out some of my work, I'll be happy to take questions either live or in the chat. You do the same idea for finding Y. You would just use one of the sides that has Y and one of the other sides. Probably the one without the variable. Makes life easier. Questions? All right, with no more questions, I'm going to go ahead and cut the recording. Thank you so much for joining us. If you're watching this on YouTube, please don't forget to hit the like, subscribe, and the bell. I have to say that in the hopes of maybe one day YouTube will pay me money for teaching this class, and then I can buy you guys pencils and compasses and all sorts of stuff for the classroom. Maybe some cool stickers. I don't know. Might be neat. Anyway, thanks again for hanging out with us and listening. Catch you guys later, and we'll see you next time.